guys, so here we're starting out the first video, or the first concept in Unit 6, which is reversible reactions. So need your notes for this. We're going to go through what examples are, the definitions, and different types of reversible reactions. So here's an example. We have mercury oxide inside of a glass tube. So the mercury oxide's right in here. It's that orangey stuff right in there. It's a solid. What we're doing is we're heating it up, and we're passing by argon gas, meaning pretty much we have this tube, it's open, and we're letting gas go through it. So what we have here is the mercury oxide is being heated up at a really high temperature. It's being reduced to become mercury and oxygen. That oxygen gas is just flowing right out. We can also have the reverse happen. So here if we have mercury liquid, remember mercury is liquid at a standard temperature and pressure, and we pass oxygen through now, we'll start to form mercury oxide. So the mercury is now undergoing oxidation to form that mercury oxide. So we're reversing the reaction that we just did. So those are reversible reactions. The forward and reverse reactions can occur at the same time. We say that they don't go to completion, meaning that they can form something else at the end. Now, not all reactions are reversible reactions, so keep that in mind as well. We'll show them with a double-headed arrow, so we might see this is one version, or the other arrow is shown here. So again, you have one arrow that looks like that. Really bad, or poor drawing of that, sorry kiddos. Let's see, a little bit better. And then the other one can be like that. Again, they're both the same thing. So what we have here is the mercury oxide. It's a solid, it's in equilibrium, or it can be, form mercury, liquid, and oxygen. The reverse can happen as well. So we can take that mercury and oxygen and form that mercury oxide. We have another reaction here. This is called cobalt, because of that cobalt right there, hexa, that's 6, aqua. So the cobalt, hexa, aqua ion, because we have an ion right there, is normally pink, and we'll be using this in lab as well. So it's a pink solution. When we add chlorine ions to it, it can form tetrachlorocobalt ion, which is a blue solution, and some water. What we could do after that is, let's erase some of that. It's a reversible reaction, so if we take that blue solution and add water to it and go in the reverse direction, we end up forming chloride ions and that cobalt hexa aqua ion again. So that blue solution will end up turning pink. We can also have reversible reactions with phase changes. So we know with water we can have a solid, go to liquid, go to gas. And those are all reversible. Of course, we can do the opposite too, from solids to gases. Dissolving can also be this process. So if we take a solid and an aqueous, or add water to it, becomes an aqueous solution, the reverse can happen. So we can take the aqueous solution, remove the water, and then becomes the solid. Weak acids and bases will also be reversible because, recall from Unit 4, weak acids and bases they won't completely dissociate in solution. So here you have the HCN, and it's in equilibrium with the hydrogen ion and the chlorine ions. So you can have the reaction go forward. Whoops, let's see. Have the reaction go forward. So you can take the HCN, produce hydrogen ions and chlorine, or the reverse can happen. These aren't going to be precipitation reactions that form insoluble compounds. So if you have a compound at the end that is not going to be able to be dissolved in water, that's not going to be reversible. So to quickly summarize, the forward and reverse reactions are occurring at the same time. You have double-sided arrows, or double-headed arrows, excuse me. So the one shown here is an example, and this one is the other example. Have a great day, guys.